Hello, everyone, and welcome to my citizen science project submission. My name is Kevin Martins, and I would like to introduce you to EteRNA. Released January 2011 by researchers from Carnegie Mellon University and Stanford University, this is known as the game with a purpose. Its purpose? The development of RNA folding sequences in a fun, creative way and accessible to anyone with a phone or an internet connection. EteRNA is the embodiment of citizen science. It allows players all around the world to participate in the creation of RNA folding sequences. The data that each player provides allows these sequences to be used in real laboratories that use it to create medical solutions to diseases and disorders. As with many things today, why not give AI a try in solving these folding sequences? Well, they did. In 2016, a group of gamers went up against computer algorithms to solve 100 RNA folding sequences. The algorithm lost. It was only able to complete 54 of the 100 puzzles, whereas the gamers completed them all. RNA folding is extremely difficult. Even today, we don't have all the rules figured out. RNA molecules are extremely unstable, and the 3D structure that RNA folds tend to take is extremely complex. Now, let's look at real-life applications currently benefiting from a game like EteRNA. Recently, we have been discussing the immune system. Vaccines are benefiting vastly from RNA folding. Do you guys remember how vaccines work? So, vaccines contain inactive parts of viruses that are injected into the body, which will trigger an immune response. Now, some vaccines require multiple doses given weeks or months apart. This is sometimes needed to produce long-lived antibodies and the development of memory cells. In this way, the body is trained to fight the specific disease-causing organism, building up memory of the pathogen to rapidly fight it if exposed in the future. Due to recent developments in RNA folding, newer vaccines contain a blueprint for producing antigens rather than the antigen itself. One of the most recent one was for the SARS-CoV-19 virus. It was the Moderna or the mRNA vaccine. mRNA vaccines are much safer than normal vaccines. It does not require the inactivation of live viruses. The blueprint for fighting the disease is the only thing going into your body. Remember when everyone was complaining as to why some vaccines like Moderna were released so quickly to the people? Well, this is why. mRNA vaccines can be produced weeks and even months faster than normal vaccines. Not only are they safer and faster to manufacture, but the shelf life of mRNA vaccines are 3 times as long as normal vaccines and are far more structurally stable. So much so that they don't require the ultra cold temperatures that vaccines need to maintain their structures. All this recent development is in part due to EteRNA. Stanford University constantly uploads challenges to the EteRNA website, and with over 272,000 players worldwide, quick work is made of these challenges. The first challenge was the Open Vaccine Challenge. This is the challenge that helped develop the mRNA vaccines. The next was OpenTB. This challenge was completed and allowed for easier diagnosis of tuberculosis in people. The most incredible of these challenges is the OpenCRISPR. This challenge will allow for better targeting of genes in any living organism that will allow doctors and scientists to eliminate diseases and disorders at the genetic level. Now let's get back to the game. I started the game on November 5th. You begin with making an account. The app is available in the Android Play Store or the Apple Store. You can also play on any computer. Once you create an account, you can play interchangeably between devices. Once you begin, you go through a tutorial that teaches you some rules. The game will alternate between individual puzzles and rules. Having spent over 4 hours, I was able to reach the top 8% of players. I completed 3 out of 5 tutorials and cleared 17 individual puzzles. And yes, you get a certificate, much like this one. Now, I'm nowhere close to completing this game, but so far I have accumulated 8,500 points. Once you reach 10,000, you get access to an in-game lab that lets you create your own RNA sequences. And once you reach 20,000 points, you can post your strand to the EteRNA community. If your strand gets the most votes amongst the community members, your RNA sequences gets to be folded at a real lab at Stanford University. Reaching the top is not easy, but the more puzzles you clear, the more data is sent to Stanford University. In the end, you're helping science regardless. Join the 272,000 current global citizen scientists trying to make a difference not only to the world of medicine, but also to make science accessible to anyone and everyone. I hope we all learned something from this video submission. Thank you very much for watching.